Good evening. How's everybody? How's the project going? Any progress?
Yeah.
We got distracted by a lab.
Distracted by the lab.
I took a little bit more focus than I anticipated.
It's okay.
We got some preliminary sensor ideas trying to throw up on the wiki.
Okay. Cool. So, how's the homework? 1 to 5 in terms of difficulty. Where would you rate the homework?
1 and 2 were.
Well, if the lab was 5, then the homework was like 3.5.
So, what kind of difficulties are you having in the lab? Yes, Larry.
I don't know how to program in assembly.
Is it the programming part, the syntax, or is it trying to come up with an algorithm?
Yes, both.
Mostly the syntax, but some the algorithm.
It's mostly just because, I mean, for me, I need to see some examples. I mean, I don't need to see somebody else do the thing I'm trying to do, but I need to see, you know, I need to solve this kind of problem. Oh, this is what the code looks like, and then I can extrapolate from that. But I haven't seen enough.
But that should be independent from the algorithm that you're supposed to implement.
Pardon?
But what you said is purely programming syntax, which is fine,
Yeah.
because you're not familiar with the syntax. But the algorithm part, it has nothing to do with the assembly of the program language. Right? So I see the algorithm part being more important in this class than the language syntax part. Because we can do examples all day, all week, right? But if you cannot write algorithms, you've just lost a huge chunk of what you should have learned in this class. Trying to transform problems and make a solution by writing an algorithm. I think that's hugely more important.
But are you finding an algorithm as an iteration through iterating through an operation until you get a result?
Yes, and that is independent of
If you write
the...
an algorithm in Visual Basic or C# or C, I'll fire one off for you.
Write it in English, even easier. Right? Write it in English first.
I could make that argument, but like on that one of those labs, I wanted to iterate through the bits. I wanted to cycle through the bit, loop through, just turn a bit, turn a bit, turn a bit.
That's
stop
fine.
a bit. But I don't know. And
Like-
so before we do that, I've got the 2 labs that are like garbage. You want me to drop those into your Dropbox right now, or?
No,
I never did that.
it's not due until this Thursday. So
Oh,
you
you
can
told us it was due tonight.
Oh, shit. Okay, so it's
stop
not.
spreading
it's not-
misinformation.
it's-
I didn't have any due date at all there, so no, the homework is due today. Not, if you can pass the homework forward.
Do you think
Scared me.
you're right, mistake?
For example, in the exam, if I'm asking you a programming question, if you're not getting the algorithm correct, will worth much more than fiddling with the syntax. Like if you use the load word syntax wrong, but you get the idea of algorithm, probably just minus 1 out of 500 or 1,000. But if you cannot create the algorithm, that's a bigger problem and will carry even more weight. Does that make sense? Think about it. Will you use PLP-CPU when you work? Unless Fritz and I suddenly get rich and start this microcontroller company with PLP-CPU, sure, right? But most likely, you won't be using PLP-CPU when you work. But you still must be able to design algorithms and be able to explain and document them so other engineers can read it. Does that make sense? So bit setting, bit clearing, coming up with a mask, that's something you really need to know how to do. And how it's useful, and when is it proper to use those techniques. Make sense? Any questions so far?
If you do get that company off the ground, we get inside track on getting hired, right? Because we're all testers.
It all depends on how the grade you get in this class. Right? So, all right, let's start. It's warning me that I'm screen sharing. Don't incriminate yourself. So last time we talked about bitwise operations, bit setting, bit clearing, masking, and we talked about shift operations, and then we talk about higher level concept, logical versus arithmetic. Of those 3 points, which ones do you think are is the hardest to grasp?
Grasp of coding.
No, just the concept. Like, which one do you still have shaky understanding of, you think?
Okay, well, how about this? I see the difference between logical and arithmetic operations as just whether or not I need to check a bit for the sign and transfer that bit to the next operation. Is that?
No. That is not. That is not how you should understand those 2 concepts, right? So arithmetic. What is arithmetic? Just some calculation of numbers. So when you do arithmetic operations, you consider the values you have on your registers or I/O device or whatever as what? As a number.
Yeah.
It can be integer. It doesn't have to be integer. You may have to do some floating point or fixed point arithmetic with decimal points or radix points. Right? That's still arithmetic. But if you treat that value in the register or in memory as a number, and you start adding stuff and trying to get numbers, compute numbers, you're doing a arithmetic. Logical operation is when you treat each bit individual.
High or low.
It could be switches, it could be some status flags in your register that says, hey, your microwave is burning, or something like that. Right? It doesn't have any notion of value. It could be. You could use it, well, if this happens, then I need to multiply this by this number. Then, based on that logical expression, you do an arithmetic operation. Does that make sense? But this is what gets people. You can use logical operations to implement arithmetic operations. That's what trips people. Shifting. If you look at the shifting mechanism, it's nothing. It's just like each bit getting shifted in positions. Like, what the heck does it mean? Right? If it's logical, well, I'm just shifting bits. Probably I just want to line them up so I can do an AND OR between multiple values. But shifting also carries some arithmetic meaning. If you shift right, what are you doing?
Multiplying by power 2.
Dividing. Right.
That's what I mean.
Right? But if you shift left, you multiply the powers of 2. Shift left is easier to grasp because it's the same. The mechanism is the same. You shifted 0, so multiplying by 2, or you're just shifting bits left. But shifting right, since we could represent a value as a 2's complement number, when you shift right, you can get the wrong answer if you don't do the correct shift. Does it make sense? Will you not be confused anymore about logical arithmetic? How about the homework? Yes.
Oh, I just said they're ignorant.
The first homework problem is pure logical. Is there at any point you think of numbers? No. What do you think of the bits in that particular problem? Value of the switches and value of the LED. There's no arithmetic involved. You may shift stuff, you may compare stuff, but not in terms of integers or something like that. How about the second one? That's purely arithmetic. But you have to do shifts. But, well, you do it, well, you don't have to get it right. But if you do use shifts for that problem, you're treating the shift as an arithmetic operation. Is that clear?
I think like the shifts when I learned about them, that was probably the hardest thing up there. But like sitting down and coding, it became pretty easy. It's just like the tricks of the bitwise operations. I guess that's just finding the algorithm. But
See, this is what will separate between good programmers, good control programmers, and passable programmers, right? Because let's say you want to set multiple bits to this operation. But if you want to mask, it's really easy. Otherwise, you treat each bit as variable if you don't understand these concepts. Does that make sense? which you can treat each bit as variable. So conceptually speaking, each bit, I'm just having one bit variables, which is fine. But sometimes the operation will be really slow because you have to actually, there'll be more instructions to execute just to set those bits. If you use masking, you can just have 2 instructions, you're done with the setting. And impress yourself, like, I did good. And nobody else will care. But in some situations, people will care. If you work for like high-performance machinery, like where resources are really limited, you may want to do it, right? So let's look at the homework. Homework 2. So light up LD7 when switches 0, 3, and 5 are set, and switches 1 and 2 are clear. So what did you do first here? What's the first thing you do for this particular problem? Yes? What's the first thing you do?
Load switches and LEDs?
Load the switches, and do you have to load the LEDs?
No.
Did you just change your mind, or is that your final answer?
All of the above.
You can't. It's mutually exclusive. Do you have to load the LEDs first?
No.
Why not?
You can load them later.
What if so that assumes the bottom 7 LEDs aren't being used for anything else. What if you are using the other LEDs to indicate something, and you don't want to mess with those LEDs? And what do you do in that case?
And then again,
So this problem, you're supposed to set this one LED, like LED 7, the most significant bit, if the switches are in certain positions.
right.
Do you care about the rest of the LEDs?
No.
What if you do?
You mask them.
You mask them, right? You load, you mask, and just you care about the 7th one, so you don't mask the rest of the LEDs. Because it might be indicating something else in your system. This is a really common bug. Like when you have multiple bits with multiple functions, and you just clobber the other bits, although they may mean something. And that's a really hard bug to find. Because what's going on? Why is this thing not firing up? Oh, I forgot to mask it. I just cleared everything up. So things like this you may encounter. Let's load the addresses of our favorite devices. So that's what's that? Address of the switches. And
Why did you use into S1? And is there a difference between, I put them into T. It seemed temporary to me.
so it's convention. It's like S means safe temporaries. So usually, like when you program in this language, the functions should not use S's. So when you call a function, it should just use T's. But that's just a convention. Hardware-wise, there's no distinction. It's just, other than the address, it's just a bunch of general-purpose registers. So when
Is this something worth learning, or is me throwing it into T okay?
It's okay when you work by yourself, but when you work with other engineers or programmers, you need to make sure that you don't clobber other people's data. Right? Because sometimes you program and this guy wrote that part, that guy wrote that part. And they have to work together.
And so the S registers are what again?
Safe temporaries.
Right, I know they're saying temporary, but translate that to what do I stick in there?
Whatever you don't want to get clobbered for the program. Something with more permanence. See, with MIPS or PLP CPU, you have 32 registers. Some architectures only have 4. So you don't even have the luxury of having a safe temporary. You always have to use what?
Stack.
Not stack, like just in general.
Memory.
Memory location somewhere, variable. Like a memory backed variable. This is also a variable, but in the register. So when you compile a program that's written in C, things that are used often, the compiler will always try to keep that in the register, because register is much faster. So that's basically what we're doing right now, because we use those often, so why use memory allocation? because you can just get it in one instruction. Cool. So now let's be proper and load from the LED and mask it off. How do I mask this off? What's the mask if we just care about the 8th bit or LED 7?
0B1 0000.
Hex, guys.
I did it in binary.
Only 4 characters to type, right? Would you see how I got it masked? Look? Like 8 is this 7. This is just, this is basically this in binary. Alright, so every 4 binary digits is 1 hex digit. That's why we actually use hex. Because if you have a 32-bit number and you write that in binary, it's a pain to write, right? So that's why we have hex. After a while, just second nature. Like, what's this in binary? 3A. In hex, sorry. So, what's next? We basically just cleared that single LED 7. So when do we set it? What's the condition that must be met before if we want to set LED 7?
It's 1, 2, or 0.
So the state of the what? Switches. So we need to get the value from the switches. Let's go in Q1. So now what do we need to do? The problem.
Why did you have to clear the LEDs?
That's not what they default.
We only set it when the condition of the switches is what we want. Otherwise, LED 7 needs to be 0. We don't know what the previous LEDs, which ones are light up or not.
Oh, you're saying if you're going to cycle through it over and over, you can reset the LEDs?
Yes. Right. So permanence. We want to make it
Gotcha.
more correct, more practical. It's not really a practical program, but you can see the idea.
Okay, so then hold on a second. So you were, when I wrote it, I just reset it every time. So you're telling me that you're putting into the T1.
Right now, after that line number 10, we should have the value of the switches on T1, in T1.
You said there could be different values in there to begin with.
We don't care, we just take the latest switch value. Because we're always sampling it, right?
Why are you wanting 0, 1, 1, 1? Don't you want to end it with all zeros if you want to reset
Yeah,
it?
that's my point.
No, we don't want to mess with the bottom 7 LEDs. That's why we're letting that value through. We want to be proper. Because as I said before, those LEDs could mean something in the program.
But wouldn't that be just as confusing if they did mean something and you weren't expecting to see anything?
No. I can give you an example where we have lights already on. And this program will not mess with it because.
But I realize what you're saying, but the program you laid out, it only gives us an LED value for 7 of 0 or on or off.
Right.
Yes,
Any other thing that our program messed up in
that's fine.
in the way you stated it to.
Yeah, that's why you always state your assumptions. Like,
But to me, that's not.
to me, this is
assumption.
clear. Like when I grade your homework or the coloring, which is fine. It's like they're just assuming that nothing is using those LEDs. I'm fine with that.
Okay.
But in some situations, you have to think critically. Right? It's like, wait. Is there any assumption I need to make? That's important. In exams, yes, Larry.
I'm sorry, I'm a step behind. So line number 9, we're anding the switches with,
No, the LEDs.
yes, anding the LEDs with,
This value. So basically what this statement does, we're clearing the last LED. The switches have certain combination.
okay.
And we're leaving the other ones alone if they're turned on.
Yes, if they're already on or off.
But also by that same argument, if it was currently, never mind.
Let's finish this first, right? So, what do we do with these switches values? Mask it off, right? What's our mask? Let's use binary for this.
Clears first. So 400110.
Yes? Why don't we combine the mask? Which bits are we interested at? 0, 3, 5, 1, 2.
I couldn't make that work in my head, so I just did 2 masks.
So if we mask it everything, then we can just compare the value of a remasked with the value we want.
How do you compare? How do you make a mask where you're trying to get zeros and ones at the same time?
Watch. All right, so we are interested in bit 0, bit 1, bit 2, bit 3. We don't care about bit 4, we care about bit 5. So that's our mask. So those are the switches that we are interested in. Make sense?
It makes sense that we're interested in them, but I don't know how I'm gonna.
So what you can do now, let's have a register that has the value that we want. Let's do an S2 because it's free. So now we can encode the values that we want. So what is it?
0, 0, 0.
We want 5 to be set. We don't care about 5 to be set. Wait a second.
0, 3, 5 to be set. No. Yeah.
Yeah, 5 to be set. We don't care about 4. 3 is set. 1 and 2 is cleared. So that's the value of the switches that we want.
Yeah. That was my second mask.
Well, that's not really a mask. That's a value that you can compare against. So I think you're just getting the terminology mixed up.
Right.
So right now, so we have, after this operation, we have the values of the switches that we are interested in.
Right.
What's next then? We can compare whether that's the actual switches that we want, like the values of that we want. So let's say we have this done here. So if T1 is not equal to the values of the switches that we want, we're done. Otherwise, what do we do? We turn on LD7. So LD7 is at T0. And if you want to turn on the most significant bit, what's our value? Or, because with an OR operation, whatever it is, or with 1, you get a 1. So if it was off before because we cleared it here. And it will only be 1 if the switches values match with this. Welcome to assembly programming.
I made it a lot more complicated than that.
What?
I made it a lot more complicated than that. But it works.
Of course. Does it?
Yeah.
That's it? That's the program?
Well, I need to make my Raymond loop.
Mine was like 35 lines long.
Can you make that a little bit bigger? So I could see the top as well.
Oh,
If that's.
I don't know how helpful that is.
Oh, I mean in the program.
Oh, you mean the vertical?
Yeah, yeah.
The height, okay.
Yes, thank you.
Let's see if this works. I hope I don't mess up and embarrass myself. Let me cheat and see the solution. Looks right, whatever. There you go. Let's simulate this. So I need my switches. Let's visualize the execution. So what is the expected output of this program?
That's it right now.
Well, yes, but what is the expected output now?
Supposedly they're going to line up LED 7, you click on 0, 3, and 5, and not 1 and 2.
Oh no, there's a bug. Oh, that's a bug. What did I forget to do? Store it back. The LEDs, that's one. Boom. But if any of this is set, it turns off. And it doesn't matter what we do with the rest of it. Just we mask those out. So how many instructions is that in the loop? Not many. If we can clobber the LEDs, we don't even need these two for this. Like you can just, this load word doesn't matter because we don't want to preserve those values, right? Let's see, like if we have like a pre-value on the LED, let's say we went to the computer and start flipping bits, or godlike power. So let's put I just turned on that those LEDs. I went into the LEDs and electronics transistors flip, right? So unfortunately we can't do that. So, but here, oops, we made a mistake. What did we do? Probably a bug in PLP12. That should not happen.
We went beyond our constraints and instructions of the program.
We broke something.
We weren't supposed to do that anyway.
Let's do it in software. I need to hunt that bug. It annoys me. See how the other LEDs don't get clobbered?
What was the bug?
I don't know. I have to figure it out. I tried to change the values of the LEDs like with the watch window. I just do that in software. So we have 0, 3, 5 lit up, but on the LEDs, but when we mess with the inputs, those don't get changed because we make sure those values get passed through. If we do it the other way, we will clobber it. Which, if you assume that it's not used, which that's fine. It just means that those LEDs should be off all the time, or on all the time, depending on how you do it. Any question? And to think that guy wrote Roller Coaster Tycoon in this kind of language.
Chris Sawyer.
Chris Sawyer's God.
We were talking about that on the way out. It's ridiculous. Why would you want to do that?
See, the alternative thing for this class is high-level programming language appreciation class.
Yeah.
So I don't think we have time to do bubble sort, but when we do that, you'll really appreciate. Oh my God, for loops! I miss for loops already. Conditionals. It's so easy to do a one-off error in assembly. Kid you not. Especially with PLP CPU assembly, where all you have is set less than. You know, sometimes you forget to check equal condition, or you're just off by 1 now. So be careful.
So this example was, that's kind of like what I wrote the program I wrote, did 2 checks, one for the zeros and then one against the actual value you want. So that's what I'm talking about bitwise operation. It's not really the function, it's just knowing these tricks and use them enough to where they become
Second nature, yes.
Yeah.
It will become second nature, hopefully. Like working with bits. It's neat. I thought it's really neat. I put up that document, that link in the class website, where there's like a bunch of neat tricks that you can do with bit mask and some arithmetic and some shifting. It's crazy. And you see all these inconsistencies in things like C. C does not define the right shift, whether it's arithmetic or logical. Can you see how it's dangerous? You cannot assume that it's going to do arithmetic. What if your input is a 2's complement number, and you assume that the shift is arithmetic, and then the system does not do that? People may die, right? So, especially if you work in medicine, like it's very stringent, like the way you write software in medicine, because it's really dangerous if you just hack on it. There's so much certification and liability clauses. But for electronics, who cares? It just reboots. Your phone just reboots, right? Just turn it on again, and it'll probably work next time. Still bothers me, but it's unlikely to kill anybody. Yes, Raymond?
Okay, so on the third line, line 13, you're loading the word, you're loading register T1 with the value of the switches, correct?
Yes.
And the value of the switches, if 1 and 2 are off, then the LED should be off. So
How did I do that?
I mean, I see, okay, I get that you loaded the value of the switches. And then the AND operation right below that, you're sticking back into that register, and you care about the 5 switches. I can see you triggered on the 5 switches.
Yes.
But how is that knowing
That's where
S2
contains the values that we want.
Yeah.
After masking them, then we're looking specifically at those 5 switches.
Yeah.
Right, and we compare it.
So basically you're telling the AND-I instruction, you're telling it, I want you to stick in register 1 those 5 bits, whether or not if they're 1s. If I have 1s and the 5 bits I care about, stick in 1s. And then you're
No, not stick in once, pass on the value.
Okay, good, correct. Pass on the value. And then you're telling it, the next step, you're telling it, compare it to the mask of S2 that you want to see only those
Yes, the
3 bits
expected
on.
value that we want, yes. So, like, it's hard to see this, but if you look at the flow chart, you can see like the branching easier. Right, so here's initialization.
I'm sorry, wait a minute. Did that program do that flowchart for you?
Yes.
Damn.
We couldn't get, we didn't work
Oh,
for
he
us,
does the flowchart for you?
Yeah, that's what I'm saying.
No. For labs, you do the flow chart first, and then on the end, compare and see if they match.
I promise I'll do that.
It's up to you, because no way for me to tell what you did, right? Other than just trusting Charo. Make sure they did the flow chart first. Yeah,
When he came over and tried to get that to work, it wouldn't work on it.
I couldn't get mine to work either.
I wrote a guide on how to do it. Like, if you go to the PLP tool page, I'm sure you guys tried. Because whatever to shortcut anything, right? The student's way.
He thought that's what we were supposed to do too. He was like, "There's a button. You just push it."
That's what Charo said. But he asked me on Hangout too. He's like, "Yeah, isn't that what they're supposed to? No, they're supposed to draw it."
Yeah, and then he came back and was like, "Just draw something on it."
So here you can, like, here it tells you how to do it. This part. You can read it later yourself. But with the flowchart, it's easier to see like how your code branches. Right. So, any question on this first problem? Because we just spent almost the whole class doing this.
Well, it was.
Which is fine.
Yeah, it was the hardest.
It's
Most
not.
of them
It's.
homework.
So you did get a second one?
Yeah.
You sure?
You thought the second one was easier than the first one?
No. I thought the first one was. Wait,
The second one is easier to code if you get it. Did you get it, Raymond?
I freely admit that I didn't get it. I don't get it, and probably won't get it.
Oh, you will get it.
That's
Don't
another
be
issue.
so pessimistic.
It was tricked, you know.
Yeah, the shifting.
Know the tricks.
Yeah. So I'm going to erase this. It'll be banished from the universe. Right. Good question. It's in the solution. So You can take it out later. Well, any question?
Someone lit up all of it, and you modified it to do that later.
We're gonna, because undo may be broken in this program. So I had an undergrad writing the syntax highlighter, and it's just it's hard to reconcile with that part of the code. So if you're a Java programmer and want to fix this error, you're welcome. This still have like at least another year of life being used in Arizona State University. So you guys are my beta testers. What's next? It's the second problem, right?
X times 18 by 4.
Why is the fact that x is positive important?
When you do a shift, negative, you get all messed up.
That's one way to describe it. So why would it be messed up if we just do shifting willy-nilly?
That is negative. The first bit will be a 1, and you're going to shift it as 0, and it's not going to be a negative.
Because our right shift in KLPCQ is a what kind of shift? Logical. Right? If x is negative and you have a negative operand, when you do logical shift, then you'll get the incorrect answer because we're treating it as a number. So how do we break down this problem?
I made a multiplication loop by addition.
I didn't have a loop, so it works.
Yeah.
It works. You just loop it 18 times.
Well, 9 times. I did. That's the same as 9 over 4. 9 over 2.
Nice, nice optimization. I like how this is heading. But did anybody do more?
Shift it 4 times, added 2, shift it back.
Yes, that's the more optimized way to do it. It's called shift and add for multiplication. Right. So basically, what you do, you can rewrite this expression this way. So what's the reverse of distribution? Where you actually split up the multiplicand in algebra. You know what distribution is, right?
Mm-hmm.
Whatever, who cares? But what I did is split up. Is it right? This is supposed to be 2, isn't it? This is 2, sorry. I had it right here. So I just basically split 18 to 16 plus 2. Well, it is distribution. And then I distribute the multiplicand, so I have x times x16 plus x times 2. Why did I do this? Because 16 and 2 are powers of 2. When you multiply with powers of 2, what happens? You can shift. Right, so after we do that, let's say we have x in S0 and we have y in it. We load x to S0 and we load y to S1, the pointers, and we actually load the value of x into T0. And for this part, it becomes a shift.
You have x and y defined?
It's assumed they are variables, so I have a pointer to each variable. So I load x to T0. So after this instruction, T0 will be x. We'll have the value of x. This needs to be shifted by 1, not 2. I apologize. So for the 16, you just shift T0, which is x, 4 times, which is multiplying by 2 to the 4, 16. And then we also want this term, so we shift T0 once. That multiplies it by 2. So now we have these 2 terms, and we add them together. So we get this part of the problem computed. And then what's next? Divide by 4, so you shift it right twice, and you should get the answer at T0. Let's try it out. Org. So what should our x be? What's a good number? 20? We'll just reserve some space for y, which will hold our result. Now let's have a pointer to x and have a pointer to y. Does everybody get why we have these these operations. We want the address of those variables. It's a load store architecture. We cannot just access the memory directly. We have to use load word or store word. And to use load word or store word, you have to provide the address of the memory location. So now we have to bring in X. And let's put it at T0. After this operation, you'll have the value of X, T0. Cool. And let's do the shifting. The first one is multiplied by 16. And so we're shifting it 4. So X times 16. The next one is multiplied by 2, right? Add them together. We don't really need T1 anymore, so we can store it there. Does it mean you see that? T1, we're done with that register. You can reuse it. So now we right shift T1 by how many? Because we're dividing by 4. We done? And we store it to Y. So T1, the value in T1 goes to 1. So that's how we don't follow. Now, if I monitor X and Y, I should have if X is 20, decimal 20, because I don't have the 0X, what's the result should be? 360 by 4, 90. Right? So let's see if this is correct. So I want to watch X and Y. X is 20. There. By the way, I added feature on PLP tool. Now you can display it as different kinds of stuff. I think somebody brought it up last Thursday, and I just had to add it. So you can show the sign, binary, the least significant byte, whatever. Yeah. So depending on what you see those values as. Now. Let's see if we get the right answer. Boom. 20 times 18 is 360 over 4 is 90. If you have noticed, we only have one explicitly arithmetic operation, add. The rest are just shifts. Pretty neat, huh? I think it's pretty neat. I don't know you guys, but the connection between the logical and using those to implement arithmetic operations, I thought was really fascinating. Any question? On the homework? No?
On the range question, you were wanting furthest negative, furthest positive number, is what I asked you.
Assumptions. If you just say certain range, like, well, there's a trick there. It's like what kind of integers?
Well, I just assumed that because the one before it asked for.
Well, this is a different kind of question. Be careful. The first one just asks for possible combinations. It has no notion of what the combinations can represent. This is a loaded question. It looks easy, but it could be confusing. The second question is explicitly asked for certain representation, what is the range? You see that? The first one, you just ask the total number of combinations. It's like what, 64K? But it doesn't really ask for any notion of numbers or range. The second one does. You may be representing 2 to the 16 different whatever, right? You already get this part? Like what bit combinations may mean and what values it can represent. Yes, Charlie. So what about this one? Return address. So when you do jump and link, it saves the return address for you. We talked about this last Monday. And what if you want to call another function, you have to actually save that manually before you can return it properly. This is also a loaded question, because I didn't really talk in detail of how to use this type. But basically, you have the base address, the pointer to the base address. You have push and pops, and then make sure you have equal number of push and pops. And when you pop in reverse order.
Your answers are right to the point.
The what?
Your answers are right to the point.
What do you mean?
I have more sentences. Blah, 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 answer, blah, 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 answer, blah, 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 answer.
So,
Answer.
why do you do that?
I'm bullshit, what can I say?
Because the more out there, the more likely you are
Yeah,
to
to
get the
not-
right one.
or it could be even less clear, and you just go, whatever. Just do this shit as a manual.
But yeah, but if you're brainy, you can just scan through and go, keyword, keyword, keyword.
That's why I did my homework one, to get you focused, right? But I don't want to do that every question. You know?
The worst part is, I think technical writing class, I should know better.
So the thing with keywords, like use these keywords, it's not to memorize those keywords. It's to know those concepts and be able to actually use and elaborate those concepts. Like if I have a big class, sometimes I have a question like use these keywords. Sometimes the students just repeat those keywords. Use these keywords. All right, address, bus.
They're just like,
I think I did that.
I don't know.
you should get half
It's
credit
graded, right?
for that.
Sure, I had it graded. I don't know if you did.
I'm not a snowden. Don't tell
I'm sure he got a good kick out of that. If you do that. So, any question? So we didn't even talk about the lecture today. So you guys now one class behind. Sorry, that's fine. That lecture will take the whole class anyway.
Just skip the midterm and then.
No, we all kind of
them.
Sure, but you'll get zeros though. That's fine.
At a zero.
Hey, just ignore that zero itself. And we can all
Be careful when you argue with me this way. Not with zero. You want negative number? You want perfect. So. Because all zeros, you have all ones. Okay, it's two's complement. You have a negative.
You should grade
My grades are not
here.
I think it's 1 here. Yeah, it's even worse than 0. Sorry. You know,
But then you would get a negative F. So that would be positive.
no, it's a 16-bit, right? So you not all zeros. So you have all ones. Two's complement. Sorry. You would have had to get 0, and then you
Yeah,
got to
but then we
get
gotta
1
switch that back
out
to
of
logical.
10 possible. Sorry, like Jason.
We would have to switch that back to logical and arithmetic, so.
I'm the architect, right? So I specify this is two's complement. So
So the test is out of 100. We make 100.
No, it's out of 1,000.
It's so awesome.
Out of
Roll this over
1,000.
to a 1.
There's an overflow.
seriously, any question? It's starting to get heavy, huh? It's okay.
Did we talk about the lab on Wednesday, maybe a little bit?
Sure. Yeah, I planned to talk about the lab, but
It took the whole time just to get us through the 2 quizzes of the homework, right?
this is why it's important to do your homework. Can you imagine if you didn't do your homework? You would be like, what the heck is we are talking about? See, make sure you invest yourself in your learning and do your homework, please. Just attempting it will be really helpful. I don't know, I didn't check who did or did not do the homework, so I'm not planning anything there, but please do your homework. Any other thing? Projects?
What does the lab do exactly?
End of this Thursday session.
And the Dropbox is in your website, I'm
No,
assuming?
no, it's OC. I'll put up the link.
Oh, indeed.
D2L.
Oh, yeah, the D2L.
And we have to use the stack on those labs? It said use the stack.
Yeah, for
Safety
temporaries, we
tickets.
didn't need to use that.
Yeah.
Okay, fine. If you can justify it, sure.
Okay.
I don't know how to do it. So it's
I know it's smart enough to ask an intelligent question like that.
yeah, that ought to be worth something.
So, like I said in syllabus, take your time. But when you take your time, make sure it's productive. Because otherwise, things just get pushed back. And it's like week 14, I haven't done that before. That's bad. Because you just missed a lot of opportunities. I won't penalize for turning lab late at all. But homework, I have to, because if others, it's really pointless if you just go to class and just, okay, this is the homework. We just went through it and just write down. We're at homework.
It's perfect.
It's not even perfect because I got a mistake in the solution that I just put up, right? So
1.0.
Well, it'd be definitely more efficient.
students and discussion grades is always interesting. Usually it becomes a bigger problem as the semester goes on. And like the last third, I don't know what I'll make in this class. You worry about that now. So just keep up. And if you have problems, just let me know about anything. I stick around after this class 2 hours downstairs. So if you want to talk about anything, homework, labs, life, your career, whatever.
You do live in Stellar, so why the hell would you have a motorcycle? Logic.
Well, who knows, man?
I didn't think about that.
So I once looked up on how to get, I like to ride my bicycle. Like how to ride a bicycle from Stillwater to Tulsa on Google. Guess what the first hit was? Somebody was killed in Fort Lauderdale. I don't know. Oh, yeah, never mind. I will never ride my bicycle from Stillwater to Tulsa. Seriously, that's the first thing to Google. Back then, I don't know if it's still true.
How many miles is it still?
70-ish, 70 to 80, depending on which ride.
I
Huh?
can run that.
Can you ride 70 miles?
Huh?
The farthest I've ridden my bike is 42 miles. Took me
I could run it in 75 miles. I bet I could do that in less than 8 hours.
Really? You're a runner?
You're gonna be late for your classes, man.
Take off at midnight, get to class, sweat all caked to the side of your face. All right.
There's an old guy who's like 70-something years old now.
All right, I'm going to stop the broadcast. This is getting.
Yeah.
Good night.